Hi everyone, in today's lesson we're going to talk about how to evaluate all six trig functions in all four quadrants. So we're going to do two examples together. So example number one says, if an angle is in standard position and P, -3, 4, is a point on the terminal side of theta, evaluate all six trig functions. So first let's graph a picture of this scenario. It says an angle is graphed in standard position and it goes through this point on the terminal side. So I'm going to start by just graphing an XY axis. And I'm going to plot the point -3, 4. So that means left 3, up 4. And we're going to label this point P. And they say point P is on the terminal side of the angle. So that means the angle terminates in quadrant 2. So if we were to finish this angle, that would be your initial side, and here would be my theta. So they want to know what all six trig functions would look like. So there's a little trick here. What we can do is drop down a perpendicular to the x-axis and make a right triangle. So what we're going to do is make a right triangle here, and we're actually going to use this theta in here. And the reason why we can use this angle is because it's the reference angle. So the reference angle gives us the same value of the function as if we were using the whole angle. So now let's label the sides of this triangle. So to get this point, -3, 4, we start at the origin and we go left 3, up 4. So left 3 would mean left 3, up 4. Now, a lot of you are probably thinking, I should label this with a negative. And the reason why I'm not going to do that is because the negative can't represent the side of a triangle, right? There's no ruler I can take out that measures this to be -3. The negative just tells us direction. So I went left 3, up 4. So I notice here that I have a triangle, or right triangle to be more specific, here, here, and here. And it looks as though we're missing one of the sides. So we're going to use Pythagorean theorem to find that missing side. Remember, Pythagorean theorem is a squared plus b squared equals c squared. Remember that c always has to be your hypotenuse. So the hypotenuse is directly across from this 90-degree angle, and that's the unknown. So we're going to say 4 squared plus 3 squared. The a and b do not matter, and we need to solve for c squared. So 4 squared we know is 16, 3 squared we know is 9. When we add them together, we get 25. And then to get c by itself, we remember that we have to take the square root of both sides. So we get that 5 is equal to c. So now that we have a perfect triangle, we now can evaluate the six trig functions. So first, let's label our picture. So with respect to this angle, the 4 is directly across from it. So we're going to call the 4 opposite. The 3 is right next to it. So we'll call the 3 the adjacent. And the 5 is directly across from the 90-degree angle. Therefore, 5 is my hypotenuse. So now that's technically all the information that we need. So we need to find all six trig functions. So we need sine of theta, we need cos of theta, and then we need tangent of theta, and its reciprocals. Remember, the reciprocal of sine is cosecant, sine sandwich. The reciprocal of cosine is secant of theta, and the reciprocal of tangent is cotangent. So the goal is to find these values. So what might help a little bit is if we write out SOHCAHTOA. So we've got so, ka, and then toa. So we know that sine is opposite over hypotenuse. So if we look in our picture, opposite is 4, hypotenuse is 5. So sine is 4/5. We know that cosecant is simply the reciprocal of sine. Reciprocal means to flip. So 4 over 5 reciprocates to 5 over 4. Now we have cosine is adjacent over hypotenuse. So my adjacent side is 3 and my hypotenuse side is 5. So I can go ahead and put in 3 over 5. We know secant is the reciprocal of that, so just flip that fraction, 5 over 3. And then tangent is opposite over adjacent, so opposite is 4 and adjacent is 3. So 4 over 3 is tangent, and we know cotangent is the reciprocal, so I can flip it and make it 3 over 4. Now we are 99.9% done. The last and final thing that we have to do is remember all students take calc. So A, S, T, C. So since we are in quadrant 2, we know that S stands for sine. So we know that sine is the only thing that's positive. Well, specifically sine and its reciprocal. So both of those remain positive. That must mean everything else must get a negative. And that's it. That's how we find the values of all 6 trig functions through a specific point. Now let's try another example. So in example number 2, the same scenario applies. I want you to evaluate all 6 trig functions, but this time I'm giving you different information. So let's analyze the information that's given. So they tell you that secant is equal to rad 13 over 2. So what I need you to pull from this is that secant of theta is actually positive, right? Because it's a positive rad 13 over 2. And we know if the reciprocal function of secant is cosine, we know that cosine of theta will also have to be positive. And then tangent of theta being less than 0, remember that less than 0 values mean negative. So this one tells me that tangent has to be negative. So we have to do a little mini, all students take calc, to figure out what quadrant we're in. So where is cosine positive? Well, cosine is positive in A and C, so here and here. And then tangent being negative would be here and here. So where's the overlap? Quadrant 4. So we have to draw a triangle that's in quadrant 4. So what helps with problems like this is if you know the bow tie. So if we draw an XY axis, we can draw a bow tie, kind of like a clown's bow tie, through the origin. And what this does is it shows us how to draw the right triangle in each of the 4 quadrants. So since we're in quadrant 4, we're going to draw this triangle. So our picture is going to look like this. We are literally only taking this piece because we're in quadrant 4. And this will be the theta. It'll always be next to the bow tie, right? The theta will always be next to the middle. So one other thing that we need is SOHCAHTOA one last time. So we've got SO, ka, and then TOA. So in the first part, they tell us that secant is rad 13 over 2. We know that secant's the reciprocal of cos. So if cosine is adjacent over hypotenuse, then this must mean that secant is hypotenuse over adjacent. So the rad 13 is the hypotenuse, and the 2 is the adjacent. So from our picture, we can go ahead and label. My adjacent side is right next door to the theta, so my adjacent side is 2, and my hypotenuse is rad 13. So again, we're missing a side of a triangle, so we're going to have to use the Pythagorean theorem. So take a minute, pause the video, find the length of the missing side, and then hit resume when you're ready for the answer. All right, this is what I got. So I knew that the radical 13 was across from the hypotenuse, therefore that was my C. And A and B, didn't matter which was which. And then 2 squared gave me 4, and I just put this into the calculator. Don't panic that it's a radical. Just put in radical 13, that thing squared should give you 13, right? Remember the radicals cancel. Isolate by subtracting the 4, and then take the square root. So your final answer should have 3. So I'm going to leave the rest of this for you guys to finish. I'd like you to now evaluate all 6 trig functions based off of this theta. And just as a hint, you might need to rationalize the denominator. We will start here tomorrow in class. All right, have a good night.